All right, good morning, everybody. I have the top of the hour, and I want to welcome you to NCAT's installation of From Research to Implementation, our webinar series for September 2025. I got an exciting topic again today. We've got high wrap and rejuvenators that are used in asphalt mixtures. There's a lot of push towards using higher wrap, and it's really neat to see some of the work that's being done with rejuvenators to try to give us good mixes with high wrap contents. So today we have Nathan Moore with us as always, Nam Tran from here at NCAT, and then we're very lucky to have Stacy Diefendorfer from VTRC. So Nathan is the Assistant Director for Test Track Research here at NCAT. He's responsible for overseeing the track research programs. In fact, they're doing somewhat of an emergency pave this week, so he's been burning the candle at both ends. Before his role that he has now, he served as a lab engineer for NCAT for 8 years. He specialized in balanced mix design and friction within the pavements. He holds his bachelor's and his master's degree, all from Auburn University here. He's a licensed professional engineer in Alabama, and I'm sure his kids are missing him today and probably tomorrow because he's a big part of their life when he's at home, and he's working late at the track getting the paving done. Dr. Nong Tran is an associate director and a research professor here at NCAT, where he leads research on asphalt recycling, balanced mix design, innovative technologies to enhance pavement durability, sustainability, and cost effectiveness. His work on incorporating recycling agents into paving application provides agencies and industries with practical guidance for building long-lasting, cost-effective asphalt pavements. Nam was also recently honored with the Industry Partnership Award from the College of Engineering here at Auburn University for all his great work with the many sponsors that he works with. Dr. Stacy Diefendorfer is an associate principal research scientist at VTRC, which is the Virginia Department of Transportation's research division, where her work is currently focused on balanced mix design implementation and responsible use of increased wrap content. Her research focused on both improving mixture durability and fostering the innovative materials and methods. And we're hoping that she remembers her English and doesn't mix it up with German because she and her family just got back from a long trip to Germany. So we're excited to have everybody here today. I want to remind you a couple things. Please keep yourself muted. Put your questions in the chat box, and we'll go from there. Nathan.
Excellent. All right. Well, you guys know the drill at this point, but for those of you who are new, I'm going to give a very brief introduction to the topic and NCAT, the history of it on the NCAT test track anyway. And then Nam will talk about his experience as he's done quite a bit of work with high wrap and rejuvenators over the years. Then I'm really excited to hear what Stacy has to say. Stacy's got a ton of experience, really on both on the academic side, but really on the practical side too. She's seen quite a bit of this stuff in her home state of Virginia. And then we want to open it up for questions. So it looks like we've got almost 40 people here today. It's gonna be great. A lot of friendly faces. So I'm really looking forward to having some discussion at the end. So just some history of NCAT's NCAT's history with high wrap and rejuvenator. Those don't always go together. At least historically, they have not. Those are more sort of joined at the hip today, more so than maybe 15, 20 years ago. And that's really with the push of balanced mix design. The first high wrap section at the NCAT test track was placed in 2006. And when I say first, it was actually multiple test sections. It was, I think, 3 or 4 different test sections, each of them with a softer binder grade. So going down to like a high PG grade of a 52 up to a high PG grade of a 76, looking at grade bumping with higher wrap usage. Some of those sections actually lasted 40 million ESAs on the track with good performance. So that was really what our sort of first endeavor into higher wrap content mixes. We've had higher wrap mixes ever since then, really on every track build. I had one 50% wrap section that this past year in 2024. We had numerous like 35% wrap, which barely even counts as high wrap anymore, especially to our friends in Virginia. That's sort of that's any other Tuesday for them. So Yeah, ever really since 2000, so almost for the past 2 decades, we've been looking at how to include more recycled materials in our mixes. Rejuvenators are a little newer than using wrap. We started using rejuvenators here at the NCAT test track. I looked back through our notes this morning to confirm this, and I'm pretty sure it was back into 2015 when I say like blending, either inline blending at an asphalt plant or terminally blended uh, in the binder. Um, Ever since then, though, we've had dozens of different products, different test sections, different applications, different dosage rates, um, utilizing Rejuvenator with high wrap. But we've also used it really for as just a BMD tool for quote unquote standard wrap mixes at this point. I like to give just lessons learned before I hand it over to our experts. And this is just from my personal lessons learned. I'm showing you just a generic rejuvenator and generic dosage rates. I'm not really trying to share anything in particular. Not all rejuvenators are the same, and it's not more does not always equal better. There's usually fine tuning necessary. You don't want to go too hot, too far. You end up having over softening. Sometimes there's sort of a point of diminishing returns, which is what I'm showing here in this particular training example that we use. Um, Sometimes these products have a point of diminishing return where you put it in and you kind of reach a point and then you're just sort of saturated and it can't, it doesn't just keep go into infinity. Um, and some rejuvenators work better than others, and this isn't really the point of this webinar, but it's just something, it's a great opportunity for the end users to try out different things and experiment for yourself. And for that matter, not all wrap is the same. We've got multi-generational wrap now that we've been you watch the stiffness and the high PG grade increase over time. In fact, back in 2021, we were looking to build new test sections at the NCAT test track, and we were looking for a wrap um, that met some certain criteria on PG binder grade, and we could not find a wrap in the state of Alabama that had a PG grade lower than 100, and that didn't used to be the case. So as you have multi-generational wrap, your wrap stockpiles are getting slowly stiffer over time, and so maybe a one-size-fits-all approach is unwarranted, and maybe more of a trial and error in dialing in specific dosage rates for specific wraps is the way to go. And I think, and many of the Rejuvenator suppliers out there have a pretty systematic approach to that. I love this picture. If anyone's ever spent time in an asphalt plant, I'm showing you the yellow line is plant temperature, and the orange and red line on the bottom. This is a 50% wrap mix, and that orange is the wrap on the cold feeds. And what I'm showing here is when we no flowed, we ran out of wrap, and the loader operator didn't get the wrap in time. Your plant temperature spiked. In this case, we almost touched 500 degrees Fahrenheit, which nobody likes to do. I bring this up not to scare people, but just to note, like, your plant runs differently as you push your wrap contents higher, and so it's really helpful to have experienced operators who you kind of work your way up, but it can be done. And it has been done successfully hundreds and hundreds and hundreds of times. So with that, I do want to kick it over to Nam for him to talk about the work that we have done here at NCAT and sort of his expertise, and then we'll hand it over to Stacy.
So good morning, good afternoon, or maybe even good evening to everyone. And thank you very much for joining us today. And today, this is actually my first time to be on this webinar. And then it's so honored and humble to be with Stacy here. She is always the role model for me to see what they have done in Virginia and what we can do in Alabama and other states here around us. So Virginia DOT have been the leading state for a lot of balance mix design work, and then they have done some excellent work that some of the data from their study have been adopted to Alabama specification. So today I'm going to talk about balance mix design with recycling agents. And some of this work actually related back to Virginia DOT special provision back in 2018. And this project is a part of our work at the NCAT test track. And you all know that Nathan is now is assistant director for the test track research. He is directly involved with this study, a lot of work that have been done by him and his group at the test track. And even Travis mentioned the award that I got earlier. Is that award is not really for me, it's for the work that Nathan, Travis, and all the people at NCAT have been achieved over the years. I was just the lucky one to get the bonus for that. So maybe I just like to have a brief acknowledgement here that this study is sponsored by Cargill at the NCAT test track. So, but their sponsorship do not affect the reason that we reported here. It's all independently evaluated, and then all the reasons have been vested by the NCAT steering committees, and then all of that. So it's really independent research, not influenced by Cargill in any way or any shape or form. So with that, this project was planned to design and produce 2 asphalt mixtures and then place them on the test track for field evaluation. The first mix was designed with 45% RAF and a bio-based recycling agents. The second mix was designed with 30% RAF and a compaction aid. And both mix was designed to balance rutting and cracking performance. The 2 mix was placed in section N3 on the north tangent of the test track. Section N3 is 200 feet long. It was divided into 2 subsections. The first subsection was paved with 30% RAP mixture. The mix had a species 64-22 and a compaction aid. The second subsection was paved with the 45% RAP with a recycling agents. Both mix was designed to meet the BMD requirements in the VDOS special provision back in 2018. At the time, Ben Bouse and Stacy was working on that specification. The APA rut depth requirement is 8 millimeter or lower. The ideal CT index must be 70 or higher, and the Cantabro mass loss must be less than 7.5 inches, 7.5%. So let's start with the mix design. The mix design process started with a 30% RAP volumetric mix design, and this whole mix design was actually conducted by Nathan Moore. Nathan Moore was very heavily involved at the time, and he was still working in the lab. And this mix design was, the 30% RAP mix design was previously approved by Virginia DOT for use in the state. The gradation was then adjusted for another mix design with 45% RAP. The both mix was then tested to meet the same volumetric requirements. The ideal CT and APA was then conducted for these 2 mixtures. The results of the performance test are plotted on this performance diagram here. You can see both volumetric design fails the proposed BMD requirements. Both data point was in the brittle corner of the performance diagram. And the 45% RAP mix show lower rut depth, but also lower CT index as expected. So the second step that we going through is to use Rejuvenator to improve the cracking resistance of the 45% RAP mixtures. And as Nathan saw earlier, we test 3 different doses for the Rejuvenator. The medium dose was selected because it provided the best CT index results. The graph show here the Rejuvenator increased the CT index of the 45% RAP mixture. It went from 20 to 40, and which is similar to that of the 30% RAP mixture. And I would like to pause here and then explain a little bit here that we are using a Rejuvenator here to improve the performance of the 45% RAP mix. And then because this one had 15% more RAP in there, the cracking resistance was much lower. So the Rejuvenator was used in here was not trying to meet the spec in VDOT specification. But just to make sure the 30% wrap make and 45% wrap make would perform equally. Okay, so once we found the optimum dose of rejuvenators, the next step was to increase the asphalt binder content for both 30% and 45% wraps. And this was done to meet the BMD requirements for cracking resistance. We added 0.3% for version AC to the 30% wrap mixture and 0.5% AC to the 45% wrap mix. As shown in this graph, both mixture match the BMD requirements. So you can see that the square blue and then the red circle now was both moved to the balanced corner of the performance diagram. Okay, so the final step is to check the mesh design. You can see here the blue box shows the BMD requirements. The orange box shows the volumetric requirements. In this case, all the VDOT BMD requirements was met, but not the volumetric criteria at the time, especially the air voice and then the VFA. Also, there are two main differences between the two mesh design. First, the 30% wrap mesh use only compaction edge. The 45% wrap mesh use a rejuvenator. Second, even though both mixtures show similar performance, the 30% wrap mesh require 4.2% version AC, but the 45% wrap mix only need 3.6% version AC. So this result in a difference of 0.5% version AC, and this may be the trade-off for the cost when we use the rejuvenator with the version binder. So based on the true BMD mesh design, the true test section was paved in the summer of 2018. Both test sections achieved an in-place density about 96% without any change, without changing any compaction pattern or rolling patterns. And then we just use the same rolling pattern with other test section that was built at the time. And the QC air voice for the plant produced mesh was only 1.5% for the 45% wrap mix. And at the time, there was a concern when we start with the BMD mesh design, if we had QC air voice too low, it might cause the rotting. So really this study to prove whether that's actually true. So we will see how the performance of those sections in the next slide. So after over 7 years and with around 25 million ISO up to this point, both test sections still perform really well. This slide shows here the field performance of the true test section on the test track. And you can see here that, I don't know if you can see my cursor, but the left upper corner of the slide showing the IRIs, and then back in 2028, the first transition of that section was very rapid, and it caused the issue with the rapidness measurement. But after we fixed that, the rapidness, or maybe the IRI for both sections are the same. The texture also is the same between the two sections, and the rutting at this point is still very similar to each other. The section with rejuvenator have a little bit higher rutting, but that is a cause, maybe because of the issue with the transition between section N3A and N3B. It has a lot more rutting in when we had to the hot stop the paper to transition from 30% wrap make to 45% wrap make when we pave the test section. And in terms of cracking, that is in graph in the bottom right of the slides. And you can see here that both sections now have the hairline crackings. And I'm going to show you some picture of the hairline crack that Jason Nelson took for me at the test track. So on the left is the crack at this moment on section N3A. And you can see here in this picture, you can see the fire start floating to the top, and then this not the failure of the base. It is just the surface of the crack. I think they are grinding to each other, and then the crack, the fire just floating to the surface when it rains. And then in section 3B, you can see that the headlight crack is still very tight. You can only see it here visually over the stripe or the pane where we mark the location where we do FWD testing. So in summary, both mixture will still perform really well, but we have several lessons learned from these experiments. Both mixture was successful design with the BMD requirement at the time. Now, we started volumetric mix design. We test them and they did not meet the BMD requirement, especially cracking. And then we use the Rejuvenator and additional version as for binder. We was able to achieve the BMD requirement for both of the mix. But again, the volumetric requirement or maybe volumetric property was not meeting the BMD requirement at the time. And then you can see here, especially for the air voice and then VFA for the BMD mix. And the second lesson that we learned is that with additional binder, with Rejuvenator, with compaction aid, we can achieve the compaction very high in the field. And both test section with 30% wrap and 45% wrap, we can easily achieve a field density of at least 96% without any change in the compaction pattern or efforts. And we also see no rutting or maybe issue with rutting, even with the low QC air voice in this case. And both sections still show very good performance with some rutting and headlight crack at this moment. And with that, I would like to thank you very much for joining us today.
I'm going to talk a little bit about the high wrap use that we have going on in Virginia. But before I do, I want to give you a little bit of context. Virginia has always been a pretty pro-wrap state. To understand why we are where we are now, you kind of have to understand where we started. 1987 to 2000, our Marshall mixes maxed out at 25% wrap, according to spec. When we went to translate into SuperPave, if you recall, SuperPave had said that above 15% wrap, you needed to do binder adjustment. Well, Virginia was saying, you know, we've already done 25% with Marshalls and we were having rutting. We don't think this is going to be a big problem. And so what happened was during the adoption of SuperPave, we compromised with the industry and said, you know, up to 20% wrap, no binder adjustments. If you want to go above 20 to 30%, you have to start doing your binder adjustments. Test your wrap binder, look at your virgin binder, and then adjust as appropriate. In 2008, we were in the middle of some cost crises. The prices of asphalt had gone haywire. And by that time, we'd allowed up to 25% wrap without a binder change. At that time, we had some work with industry, and it was proposed in part because of the SBS shortage and cost of our 70-22 binder, that if we put 25 to 30% wrap in a PG 64-22 mix, that it would on average come out to be about a PG 70-22. And so that was evaluated in 2007 and adopted into the 2008 specification. And that's been the case all the way up to BMD. In 2017, there was additional interest in running high wrap, particularly by industry. And we were tasked with developing a high wrap special provision that would use performance testing to guide the use of the higher wrap. And that ultimately resulted in our balanced mix design high wrap special provision. We did a little shadow testing in 2018 on standard mixes. But 2019 through 2021, VDOT was allowing, with the special provision, the production of greater than 30% wrap. If you were below 30% wrap, you use the BMD dense graded special provision, which is basically the same as we're using today. Some updates in the testing, updates in production testing, but it's basically meant for our surface dense graded mixes with no polymer. We still do not apply BMD to polymer. So along with this, we had looked at some high wrap way back when, 2013 and 2014, just for fun. I honestly don't remember how it got started, but there were discussions, and I think it boiled down to industry had been successful in the 80s and 90s in running high wrap in municipal mixes, non-VDOT mixes. And said, well, you know, if we could do this with super pave or pre-super pave, why can't we do this during super pave? And ultimately, we decided to do some tests. In 2013, we put down a series of 5 mixes, 3 of which were various controls, a 20% wrap mix with a 70 minus 22, a 30% wrap mix with a 64 minus 20, well, 2 30% wrap mixes with 64 minus 22. You'll notice that there's some notes about natural sand versus manufactured sand. The contractor that we were working with was looking at some of their sand blends, and so we applied that within the context of the project. But we did 40 and 45% wrap with a 64 minus 22. No binder adjustments, no anything. Granted, we were augering fines out of the bag house to keep everything from having problems. And the 45% wrap, we actually only ran about half a day of it because we found that we just couldn't maintain the super pave properties with it. We were having some issues with the fines, and quite frankly, we couldn't take anything else out because we had so much wrap in there. So we dropped that mix to a 40%. Those mixes have been trafficked. They had a chip seal applied, I believe it was in 2022, just to get some extra longevity out of it. But, you know, 9 years of service and only needing a chip seal is not a bad thing for something that we were really going into with best hopes and fingers crossed. That same year, we had a contractor want to run 40% wrap down on our southeastern part of Virginia in the city of Hampton. We went out and sampled that. The same year we ran in central Virginia, central western Virginia, in Lynchburg district, 4 more mixes. The idea was we were trying to figure out where these 40% wrap mixes would fall. Would they be closer to something like our 70 minus 22 mix, which was our intermediate traffic mix, or would they be, you know, just a stiffer version of our 30% wrap mix that at the time was serving as a lower volume and intermediate volume mix. In this case, we ran, I believe it was a mile each of the mixes, 30% wrap, 40% wrap, and 45% wrap. And I can tell you that was interesting. We found out that the wrap screens had to be resized for some of these quantities of wrap. The plant that we were running with, they just hadn't run high wrap out of that plant. And so we were doing a little bit of keeping our fingers crossed that everything would work out because we were basically overloading our wrap screen. Then in 2014, we went back up to Fredericksburg, and the contractor that had done the first job with us, they wanted to try a different version of it, and they wanted to drop the binder to a 58 minus 28 and see what that would do. They thought we could do better than our 64-22 40% wrap mix and get a more durable mix. And so we paved it in 2014. That mix is still going strong today. I haven't been out to core it yet, but the PMS data on it's pretty good. Minimal cracking, no worse than any control mix that's along with it. And we're starting to monitor these mixes closely this year. So we came into our BMD specification. We're using the IDT-CT with a limit of minimum of 70. Initially, we were using the APA rut test with an 8mm max, Cantabro test with a 7.5% max mass loss, and VDOT has always had a TSR spec, 80%. I will say that, some folks have issued concerns about moisture susceptibility with high RAP. We have not seen any issues, but I believe that's primarily because VDOT is a state that requires a liquid or lime anistrip in every mix. It's that extra insurance. And you can see when we designed BMD, we were looking at this from design and production. We were charged with not only saying, can you design the high RAP mix or a standard mix with BMD, but what can we do towards acceptance testing? So as we were choosing tests, with the exception of the APA, because there weren't a whole lot of options back then, the idea was, could these be production tests as well? So we took on BMD in 2019 and 2020. And in our case, for all 6 of these projects, we had one project that did not use high RAP. Clearly, one of the benefits of BMD to the industry is that it allows the use of the RAP. And in Virginia, particularly in our urban areas, that is a big issue. Storage of RAP, handling RAP, what are you going to do with that stockpile of RAP? And this has been one of the reasons that BMD has been kind of embraced by our industry, was that they see it as a way to innovate, but they also see it as a way to help absorb this RAP use. From 2019, you can see the top study here in Northern Virginia. This one, we started with 3 mixes and went a little crazy and kept on going. We had 2 controls with 30% RAP, one with a 64S -22, one with a 58 -28. And then we had 40% RAP. We used a small paving. We were kind of worried about it, so we didn't do but a little less than half a day of the 40% RAP with the 64S by itself, knowing that was going to be much more brittle. We also ran 40% RAP with a recycling agent and 40% RAP with a PG 58 -28. We basically continued this sort of series with most of our BMD high RAP projects. There's usually a control, a mix with a recycling agent, and a mix with the PG 58 -28. And with each project, we looked at different recycling agents. In 2020, BMD, of course, was still rolling strong, and we decided to go ahead, push the envelope, and use our accelerated pavement testing facility at Virginia Tech to look at how high could we go and what could BMD allow us to do with high RAP. So we paved 6 lanes of our accelerated paving testing with mixes. We used a super pave control that was basically our standard mix of the time, 30% RAP, 64S -22, and a warm mix additive. A lot of our mixes in Virginia tend to have warm mix additives, not necessarily for lower temperature paving, more as a compaction aid. And also, since so many of the warm mixes at lower dosage also work as the anti-strip, it just makes it an easy thing to add that has opportunities to give benefits. We took that 30% RAP mix and optimized it using BMD testing, and put that out. And then we designed 3 45% RAP mixes. All were off of the same aggregate structure, basically. Don't believe they changed very much, other than if the RAP changed a little bit and we had to adjust for that. 2 of them had 64S -22, one with just our warm mix, one with a recycling agent, and one with the binder drop to 58 -28. And then we decided, well, the whole point of an APT is to put out things that you might not want to put on a public road and see what they do. So we designed a 60% RAP mix. You can see what the RAP belt looked like here on the right, with 60% RAP. It was full. This plant was not set up necessarily for 60%. But the producer that we worked with did a fantastic job of testing all of the mixes before we started production, doing some troubleshooting, making sure that as we learned from our mistakes starting at the control mix, that they modified what was necessary to make the next mix more successful. And that 60% wrap mix went down great. I really, I don't know. It's really exciting to me to be kind of pushing that limit and being able to see that it works. You can see some of the paving at the test facility on the bottom left. These were very, very small paving jobs, but very highly controlled. We had very tight tolerances on lift thickness, very tight tolerances on our volumetrics and our voids density. Basically, we had an aggregate base and we put 2 1.5-inch lifts of each of our 9.5 millimeter mixes on top. The idea being we were going to evaluate both rutting and cracking, and we wanted to make sure that we had the best chances of introducing cracking into the mix eventually without it taking 10 years. In the middle, you can see these sections were also instrumented. So we had strain gauges, pressure cells, thermocouples, forget what else out there. Continued moving on with higher wrap and BMD pilots. In 2021, VDOT introduced BMD into our plant mix maintenance schedules as a bid line item. All the work beforehand had been done by change orders. And so when we did this as a bid line item, it mostly focused on standard 30% wrap mixes or below being designed with BMD. For one contract, Northern Virginia, which is one of our urban areas in Loudoun County, opted to go ahead and try a high wrap mix out in the wild, so to speak. And we ran a control mix, but split between 2 routes. It was about, I think, 3,800 tons. One route got the high wrap BMD P, which was a performance only design of a 40% wrap with a 58 minus 28. And one route was to get what we called the P plus V, which was our performance plus volumetric design. The idea had been that we would let the contractors do their performance plus volumetrics, which would give everybody a little sense of, reassurance because they would still meet volumetric requirements. And then we would take those, take off the reins and turn them loose and say, okay, here's a performance only mix. Do what you want as long as you meet the performance requirements. Unfortunately, that year, combination of the way schedules worked, the way the weather worked, there was not enough time for the contractors to actually do the P design. So we ended up, even in our standard mixes that had a P and a P plus V option, both mixes were designed as P plus V. That was perfectly legal the way the spec was written. The P just let you take the V off, basically, and run without or design without the volumetric guardrails. But they ended up both being the same mix. So we really didn't get in that point to the opportunity to analyze, what happens with a performance only design. So those were pretty interesting. Unfortunately, that was the last use of the high wrap BMD special provision to date. So, why did we stop? The big thing is risk management. With higher tonnages comes more risk. And as a DOT, we're really not in the business of putting a lot of risk out there. If one of these mixes happens to fail, somebody's going to have to pay to go back out there. And the taxpayers really don't like to see us back out there any sooner than they absolutely have to. Knowing the properties of BMD mixes, we had been seeing nearly equal performance to the 30% wrap mixes at that point. But there was still concerns about cracking resistance because at this point, if you looked at our BMD mixes, we'd only been doing them for about 3 years. So, I don't expect, at least I hope nothing's going to crack within the first 2 or 3 years. So we didn't know what it would do 4, 5, 8 years down the line. At that time, we had no method to evaluate whether the RAs were actually being effective. We were essentially working with the manufacturers, assuming that, you know, all of us are in this to move this forward. So they're not going to give us something that's going to be, you know, some sort of snake oil or, you know, not work. But we still didn't have a way to truly evaluate how well the RAs were working. VDOT did not have a method to approve RAs. We need to put something like that on our product approval list. And because of that, looking at that long-term cracking resistance, there was no aging procedure or threshold. So what did we do? Well, we said, okay, well, you know, here's what's holding us back. So we're going to move forward. The first step taken was looking at a framework to evaluate the recycling agents. That study's been complete. It showed very clearly that the recycling agents can enhance performance. It can allow you to increase the recycled material use if the correct and suitable dosage is determined through the performance-based testing. What we found that it was a combination of looking at the binder testing and some of the mix testing. And so that set up an initial framework. If you're interested, the report is online. You can come to VTRC's website, download everything for free. But it's VTRC 24R3. That established the framework, but we wanted to verify it. So the next project looked at how do we develop our approved product list using that framework. It developed a rejuvenation path index that allowed you to model and predict recycling agent dosages to get that wrap binder back to a performance-based, I want to say kind of a performance-based condition that was very similar to our virgin binders. We found out that that rejuvenation path index was independent of the dosage, and it could be used for the acceptance of other RAs. And that framework established a preliminary cracking tolerance index aging sensitivity of 45%, meaning that, you know, you're going to test your mix, you're going to age it, and you're going to test it again, and you're going to have to retain 45%. The results of that work are in VTR 626-R09 for verification. There's still another step in this, but first, we also looked at aging and long-term cracking performance. The results of this study, you know, and these were multi-year studies, so, you know, we're talking 2, 3, 4 years. At design, we now use a 6-hour oven aging at compaction temperature. We started off with an 8-hour condition, and we also have aging that we can do during production. If you are taking a mix and reheating it, you reheat it plus 2 hours at compaction temperature. If you're taking hot mix straight from the plant and doing hot compaction, you age it for 4 hours at compaction temperature before making your pills. And the preliminary value for the age CT index is 55. That's in report VTRC 26R04 that just came out a few months ago. But all this is available if you're interested. So here we have some of these steps forward. Finally, the next steps, I'm trying to watch time. Right now, we're doing field validation of that recycling agent acceptance framework. The framework's being used to accept the RA as a product, to look at the dosing, and then also the framework applies during design with long-term oven aging and aging sensitivity requirements. In these projects, we're including a control BMD mix when possible so that we can have a straight up comparison. And we're in the process of monitoring performance of those projects. That is ongoing work right now. High wrap field performance, we've got over 10 years of information on the early high wrap mixes that were made with super pave mixes. And we're approaching, well, we are in year 6 of the early BMD mixes. So we're going out right now. We're evaluating pavement structure, FWD, doing condition assessment, pulling up the PMS history of these sites where we have, you know, intermittent data on them. coring the sites, testing cores, doing binder extractions, the whole 9 yards to characterize what's going on, if they have a problem, why is there a problem, and looking at the actual field performance of high wrap mixes. And that's really going to kind of guide where we go forward. It will be complete next fall, and I'm hoping, I'm keeping my fingers crossed, I like to think I'm an optimist, that this will be very positive outcomes and we'll be able to go back to looking at more high wrap. But as always, that's to be determined. And with that, I'll say thank you and hope I didn't run over too long.
Nope. Stacy, that's exactly why we asked you. That was really, really great. Again, sort of straight off the bat, not all wraps and rejuvenators are the same. This isn't a statement about like some are better than others. It's a statement of wrap is different and it's going to change. It's going to change based off of where you pulled it from, the job you pulled it from, when it was placed, what mix design it was, et cetera, et cetera. And not all rejuvenators are the same. Some of them work differently than others. Some of them have different chemistry. They have different chemistries and different purposes and different applications, different dosage rates, et cetera. So it's an opportunity for innovation, but it's also not like a one-size-fits-all approach, which really bodes well for, as Stacy talked about a lot about BMD, which we'll get there in just a second. Nam and Stacy both touched on this a little bit. Nam probably a little bit more. Relaxing volumetric requirements is appropriate for high wrap mixes, specifically on volumetric requirements or parameters that previously were indicative of rutting performance. Definitely relaxing things like minimum air void content is appropriate. I mean, I would actually probably personally say it's recommended. But it's definitely something that I don't think you have to do it overly cautiously. I could have done a whole webinar on how many low void mixes we've had on a track with over 20% wrap in them that have been just fine. Nam's, some of Nam's slides were really helpful as he talked about density. Good compactability and density is achievable with these high wrap mixes when they're rejuvenated in some sort. So, typically you would have really stiff mixes that have high wrap in them, and it'd be really difficult to compact. However, that's where sort of the marriage between high wrap and rejuvenator really shines, is because you can create this mix that would be previously difficult, I mean, almost impossible, but definitely difficult to construct. And now it flows just like a regular, standard mix. I hope that for the participants online, I hope you got as much out of Stacy's talk as I did. Stacy, I actually have a question for you when we get to that part. But one of the big takeaways I got was cooperation between the agency and industry is necessary. It's paramount. Can't do it otherwise. And so from agreeing with one another on how to set up trials or where to set thresholds and being transparent. I've actually been somewhat involved in how y'all came up with your numbers years ago. Being transparent with how you do that is really, really helpful. And it's some give and take, right? So if the contractor wants to use more wrap and you're saying, all right, you're asking me to allow that and maybe even relax voids or something like that, like, well, we need this from you. We need to make sure that we're purchasing a high quality product. So it's definitely necessary, and I can't dote on Virginia enough and say I think they've really set a great bar for what a good partnership between an agency and industry looks like, and a lot of that, I give a lot of credit to Stacy for that. And then finally, to round out the webinar and then get to the questions, is BMD is the key to high quality, high wrap mixes. Not to say you can't do it without BMD, but it really opens the door and widens the goalpost, so to speak, of the kinds of mixes that we can produce with higher wrap. Some of the stuff that Stacy talked about, having 60% wrap, for example, I would be hard pressed to find a mix designer who could put a 60% wrap design blend together and meet your typical super pave criteria, 100 gyrations, meet dust proportion, etc. But when you're focusing on performance and quality of the mixture itself and the materials, you can do it. And so I really appreciate Stacy's discussion on how you guys developed not just your threshold criteria, but also your aging parameters and your rejuvenator indexes, which I'm curious what about that as well. With that, though, I'll stop talking. And I know we actually had quite a few questions come in the chat. So, Travis,
Yeah.
I'm going to let you moderate that.
Awesome. We've had some good questions come in, and actually, one of the last questions that just came in, I think, is one I want to go to first. And that question is, how were these recycling agents, introduced into the mixture? And I think both Nom and Stacy probably have a perspective on what was done here at NCAT and what Stacy has seen with their contractors there. So, Nom, you want to go first on the different ways that the recycling agents have been introduced into the mixtures?
So we have multiple ways. We had tried multiple ways. The first one, the easiest one, is only blend it through the virgin binder. That's one way. Number two is that we have used that with the inline blending, and then we do it at the asphalt plant. We also had the ring that Buzz actually designed and put around the wrap collar, and then we spray directly to the wrap before we go into the drum. And then we also have some other study to look at pre-blending of that and then marinate it in the field. And at the end, we see that there's not much different. And then actually Fan also did a study to look at how we can do actually foaming to improve the blending rejuvenator directly to the rack. And then at the end, the conclusion is that not much different if we do different way compared with the standard procedure to blend with the virgin binder. And that is have been the way that we hope that will be the future. But again, we're only open to other opportunity to evaluate if something may work better.
Yeah, great. Great. Stacy, how have the agents been introduced in the mixtures there in Virginia?
We've primarily been doing inline blending, mostly because we're already comfortable with it because we're putting in the anti-strip with inline blending.
Okay.
And so it's
Yeah.
pretty easy for our contractors to just slip everything in. And with the quantities that we've been doing, some of them have been on the small side, so it doesn't make sense to get an entire tanker blended.
Sure.
And then if we're on the large side, you keep having to order tankers to keep up. So the inline allows the contractor to be very flexible and turn it off and on as needed.
Stacy, what kind of does the state check dosage rates, or how do you monitor inline blending, or is it something where you only care about the final result?
I'd like to say we only care about the final result because that's where we want to be, but no, there's requirements on calibration and verifying.
Okay. How do you, is it, you just do like a volumetric method? Like you look at how much you use versus how many tons you ran, or how do you check that?
I think typically, yes.
Okay.
For the studies that we were doing, we were really just monitoring it, based off of, what quantities were coming through and how much we're using at any given point, because it was smaller dosages, or smaller tonnage. But yeah, there's I have to be honest, I'm not sure exactly how it's done for all the anti-strips because that's not my area.
Sure.
But it's all
Sure.
built in because we do require that. And there
Yeah.
does have to be verification.
That makes it easier. And then I assume that your pumping system for the inline blending is tied into the plant controls so that if it stops,
Yep.
right? Because I've heard horror stories of other types of additives. When they go to check the barrel's empty, but there was nothing tied to the controls to verify. So
Yep.
Yeah, for the most part, ours are. In a couple of places, it was separate because the way that we were pulling in the
Sure.
additive material. And so it was, you were monitoring on the fly rather than at the controls.
Sure. All right. Another question I've seen has come up here a little bit is why use a lower compaction temperature for a mix that's got a higher wrap content, and how do you determine that? So I think both of you, if you have a chance, Nom, do you want to go first on that one?
I think maybe it probably going back to some of the work that Stacy had been on the panel with the NCARP to look at the bioavailability. And then it does show that at the higher mixing temperature, we see more blending of the wrap binder with the virgin binder in the total mix. So I think that depends on how the state implement that, it may affect the temperature, mixing temperature in the field. But the argument for that is not every state or not every location in the country will have to have the same very high mixing temperature. In the northern part, when the wrap binder is much softer than the one in the south, or maybe if they're not using shingle, they can lower temperature. It doesn't have to be 300 degree Fahrenheit or 350 degree Fahrenheit, just like we're currently using right now. And then a lot of that is really the contractor never check whether they can lower temperature or not. They probably set one temperature and then let it go all the time.
Okay. Stacy, your thoughts on lower temperatures with higher percentages of wraps, and then how do you pick your temperatures?
We use our standard temperatures, and we've got the allowance for warm mix temperatures. But to me, it's kind of a competing balance. You don't want to keep increasing that mix temperature and have issues with your virgin binder. We don't want to prematurely age that.
Sure.
Yes, we want the wrap hot, so it's available. You don't want to add any more aging to that either. You want it usable.
Yeah.
And so that it can blend, but you don't want to overdo it.
Yeah.
So kind of 6 on one hand, half dozen on the other, how you can approach it.
And I think this is one of those points that really speaks to Nathan's point, last bullet on the recommendations about using some performance tests in these types of mixes, because there's, has anybody really decided, are we activating all the binder or is it black rock, right? That argument still happens so much. So if we can base this off of the performance of the mixtures, then we can get away from that argument and experiment with producing at much lower temperatures, which would be great for energy efficiency and everything, if that still works for us. So excellent. There were some questions on dosage rates in here. I assume that's vendor specific. Is that correct?
The dosage rates are typically vendor specific, but there are also some questions about the wrap sources, specifically NOM. What was the high PG grade
Oh yeah.
or what was the PG grade of the wrap that Cargill used?
Both high and low.
So that one is about maybe 90s, in the 90s, the high PG grade of that wrap.
Do you know the low grade?
I don't remember low grade.
It's probably to whoever asked that question. It may have been Dave, or Stefan. That information is going to be in the report. It's on the NCAT website, and NOM's already wrote up something on that. You can look it up in the most recent test track report. You'll find it there.
And then Nathan, maybe just add to that wrap is coming from Virginia too. So it's a little bit softer than the one that we had in Alabama.
My guess is that one was probably a -10, maybe a -6, but more likely a 10.
Yes, -10 or -16, one of those numbers.
Great. And one of the questions, Stacy, that I have personally in my mind is, as you move forward with trying to use these rejuvenating agents and opening that up to more than just a single company or two companies, do you guys consider using like the AASHTO Peas program for acceptance, or how are you guys currently accepting these or verifying these agents?
Right now, we're in that kind of limbo where we have the framework that we've done research on and are validating it.
Mm-hmm.
I honestly don't know what I'd have to talk to materials division to know what they're thinking as far as moving forward with the AASHTO program.
Sure.
I mean, I think both have merits. AASHTO gives a broader coverage, but if a state's doing some testing on their own, you know what it does with your specific materials.
And that goes back to sort of what I was saying, where some of this stuff is very material specific. and that's the beauty of balanced mix design.
Yeah.
But it does put the impetus on the contractor or the partnership between the contractor and the person selling them a product to work together and figure out what that optimum dosage rate might be. That's how we've done it anyway.
Same here with us.
Cool.
The contractors have teamed up with their selected recycling agent supplier. We haven't dictated
That's right.
anything other than please make it not be something that nobody has ever heard of before. We don't
Right.
need to be quite that guinea pig level.
Send that stuff to NCAT. We'll handle that.
Yeah.
There you go. Stacy, any consideration going with polymer modified asphalts, or do you guys do any testing using the MSCR with high
We
mix?
are an MSCR state already.
Okay.
We've been looking at BMD relative to polymer modified. The thought really with the polymer modifieds is that we're really paying for that elastomeric performance. And quite frankly, the question is, are we willing to potentially dilute that performance with a wrap that probably doesn't have polymer modification in it?
Yeah.
Or if it does, it's aged, it's changed chemically. And I mean, everything I've seen about the recycling agents, I haven't seen anything that proposes that they return a polymer modified binder to that level of elasticity.
Yeah.
And so, we only use our polymer modifications. Those are our interstate and high volume primary mixes. And so those are kind of sacrosanct. You don't mess with the SMA and the polymer modified mixes.
Yeah.
In terms of what might have any issues with quality.
Sure. All right. Well, I think we've lumped a lot of these questions together here because they were kind of close to each other, but we gone a little bit over, but this discussion was too good to stop. So Nathan, you want to close us out?
Yeah. Many of the questions you guys asked today about specific stuff to what Nam talked about, you can actually find that information in the report. So you can go to the ncat.us and go to either our research, and then you can find the report that way, or you can go to the test track and find the reports this way. There's probably about 2 other ways you can get to the reports as well. Use your search engine of choice, but you can click on the phase 8. It's actually no longer in draft. It's actually a final published report at this point.
And Nathan, maybe I should add is that if they couldn't find it, they always can email either you or Travis, and then you get them directly to the section of the report.
That's right. So anyone who's interested in more information just about asphalt in general, or if you're especially if you're new, or if you know people are new, this Training in Your Pocket YouTube channel that Travis runs is a great resource for that. Have you done one on high wrap, Travis?
No. Why don't you help me write a script? Let's do one.
Oh, wait, my mom's calling me. I couldn't hear you.
Yeah, that's right.
Anyway, so it's a really great resource, and some basic stuff about 4-part series on volumetrics to understanding the different forms of compaction, static, vibratory oscillator, things like that. It's a great resource that I would highly recommend to folks, especially if you've got folks on your team that are newer. It's just a good introduction, bite size. So with that, we are done for the day. I do thank you to everyone who hung on a little bit longer. This was a great discussion.
Yeah.
Thank you again to Nam and Stacy, top notch. You guys are wonderful. I really appreciate you guys taking part of your day to do this. Next month, we'll be talking about thick lift paving. And so tune in. That's going to be October 16th, same time, 3rd Thursday of the month at 10 o'clock Central.
Okay. Sounds good. Thank you, everybody.
Thanks, everybody.
See you next month.